welcome to another exciting journey into the world of physics. Today, we will be exploring the types of motions, speed, and their graphical representation. Imagine a race car zooming around a track. That's motion. And how fast it zips by. That's speed. There are three main types of motion we'll cover. Linear, like a sprinter racing in a straight line. Rotational, like a spinning top. And oscillatory, like a child on a swing. Now that we have a basic understanding of what motion and speed are, let's dive deeper into each type of motion. First up, we have linear motion, a type of motion in which all parts of an object move the same distance in a given time. Picture this, a car moving in a straight line down a highway. No swerving, no turning, just straight ahead. That's linear motion. Now, let's bring in the concept of speed. Speed, in the simplest terms, is how fast an object moves. In our car example, it's how quickly the car covers the distance on the highway. Speed is calculated by dividing the distance traveled by the time it took to travel that distance. But what does this look like on a graph? Imagine a straight, upward sloping line on a graph. The distance is on the vertical axis, the time is on the horizontal axis. As time progresses, the distance the car travels increases, and so does the line on our graph. That was all about linear motion. Now let's move on to our next type of motion. Next, we have rotational motion, a type of motion in which an object moves in a circular path around a fixed point. Just imagine a spinning top. It's not going anywhere, but it's certainly not standing still. That's rotational motion for you. Now let's talk about speed. When it comes to rotational motion, speed isn't just about how fast the object is moving, but also how quickly it's spinning. This is often measured in revolutions per minute. So, if our spinning top makes one complete turn in a minute, its speed is 1 revolution per minute. Graphically representing this isn't as daunting as it sounds. Picture a line graph with time on the horizontal axis and speed on the vertical one. As the speed of our spinning top changes, we plot these changes on our graph.
जीवन अनमोल है, खुशियां बांटे, अच्छा रोल है. कल को आसान बनाने के लिए आज आपको कड़ी मेहनत करनी ही पड़ेगी.
Creating a visual representation of the top's rotational motion over time. That's rotational motion for you. Let's now explore our final type of motion. Finally, we have oscillatory motion, where an object moves back and forth repeatedly about a fixed point. Imagine a pendulum swinging back and forth, back and forth. That's oscillatory motion in action. The pendulum doesn't just wander off anywhere. It's bound to its fixed point and swings around it. Now how about the speed of an object in oscillatory motion? Well, it's not constant. The speed varies, being fastest at the bottom of the swing and slowest at the top. It's a rhythmic dance of speed, mimicking the rhythm of the object's motion. And how do we graphically represent this? Picture a wave. The speed of the object in oscillatory motion can be represented by a sine wave, with peaks representing the highest speed and troughs representing the slowest speed. With that, we have covered all the types of motion and how speed is represented in each. A fascinating world, isn't it? That brings us to the end of our whirlwind tour of motions and speed. We've journeyed through linear, rotational, and oscillatory motions and seen how speed can be graphically represented. Remember, these concepts aren't just fascinating, they're crucial for your journey in understanding the physics that shapes our world. For more such interesting and informative videos, do subscribe to our channel. And if you need any further help, feel free to contact Students Care Center. Reach out to Anil Sir at 9999060986. Until next time, keep exploring the world of physics.